In lesson 5.4, we're talking about oblique triangles still. So those are triangles that don't have a 90-degree angle in them. And we already learned law of cosines, and we also figured out how to find the area of such a triangle. And now we're going to be able to do the same thing that law of cosines did, only using a new equation called law of sines. So, law of sines. If you want to pause the video and write these down, this is the same formula, just written as reciprocals of each other. So it's just you're setting up a proportion. So law of sine says that sine of angle A divided by side A is equal to sine of angle B divided by side B. And that is also equal to sine of angle C divided by side C. Normally we put sine on top if we're looking for the angle, and then we would put the side or sine on the bottom when we're looking for the sides. But it doesn't really matter which version you're looking at. Whenever you do use these, you're only going to set up two at a time. So you're just going to set up one proportion, and then you'll cross multiply with them. So even though I wrote three, you only use two at a time. Example 1, let's draw this triangle, and we will probably use law of sines, since that's the notes that we're taking. Okay, let's see, angle B is 64, and angle C is 38, and side B is 9. And they want us to find both sides C and side A in this problem. So when you look at law of sines, you want to look for opposites. So let's see. Right now, I have opposites for B. Oh, that highlighter doesn't work. Hold on a second. All right, so I have angle B, and I have its opposite side, side B. When I look at C, I have the angle for C, but I don't have the side for C. So 38 and C are opposites of each other. And when I look at A, do I have a different color? When I look at A, I don't have anything for A. I have no angle for A, no side for A. So ask yourself, how could I find angle A? And if you remember, in geometry, all triangles add up to 180. So if we do 180 minus the other two angles, so this is what I'm doing, 180 and subtract the other two angles, you get 78. 78. So if you want work for that, we did 180 minus the other two angles. Okay, so now I do have an opposite for A. So I have an opposite for C, I have an opposite for A, and I have an opposite for B. Now, you want to use the one that you have both opposites have numbers for. So we're gonna use B in order to find the other two. Let's find A first. We're gonna use B to find A. So I'm looking for A over sine of whatever angle A is. You set that equal to what you do know. We know B over B, so we know 9 over sine of angle B, which is 64. So that's how I'm going to set up my proportion. Whenever you set this up, you should only have one unknown variable. Everything else should have a number in it. So from here, you cross multiply. Multiply your diagonals together. And then how would I solve for A? I would divide sine 64 to the other side. So that means A is going to equal 9 times sine of 78 divided by sine of 64. So go ahead and type that into your calculator. Make sure you close parentheses on your trig function. So it'll be 9 times, make sure you're in degrees, sine of 78 degrees, close your parentheses, and divide that by the sine of 64, and make sure you close your parentheses. I'm getting 9.79. 9.79 for A, which is very comparable to B, which was 9. So my answer makes sense for what I have been given. Now let's set up the proportion to find C. Now let's remind you cannot use Pythagorean theorem to find C because it's not a right triangle. So you can't just do a squared plus b squared equals c squared. You're going to have to set up this proportion like we just did for A. So if I'm looking for side C, I'm going to put that over sine of angle C, which happens to be 38. And I'm going to use B again. Just in case you got A wrong, try to use the one that the problem gave you, if you can. Just in case you get your other answer wrong. So 9 over sine of 64. Cross multiply again. So you're going to have C times the sine of 64 equals 9 times its diagonal, sine 38. Then we're going to divide sine 64 to both sides, which is going to give me 9 times sine 38 on top, divided by sine 64 in the denominator, and type that in. So we have 9 times the sine of 38, close your parentheses, divided by sine of 64. And I'm getting 6.16 for C, which is also very comparable to the 9s that I'm getting for the other side. So I can trust that my answers are correct. In example 2, let's draw that picture. Side A is 8, angle B is 64, angle C is 38, and side C is what they want us to find. So let's look at our opposites. We've got angle B is opposite of side B, which they didn't talk about. We have angle A is opposite of side A, which is 8. And we have angle C is opposite of side C. So let's set up our proportion. You have C over the sine of 38 equals, I have to use 8. That's my only other side. But I need the angle for A. So do the same thing we did earlier. Subtract those from 180. 180 minus 64 plus 38. 64 and 38, which is going to give me 78 again. So I get 78. We're going to cross multiply. So we're going to have C times sine 78 equals 8 times sine 38, and divide sine 78 to the other side to isolate your C. And type that all into your calculator. So you're going to have 8 times the sine of 38 divided by the sine of 78. And I'm getting 5.04 if you round.